Welcome viewers, in this video we will see the solved problem based on the DC transient response of RL circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the problem. The statement of problem is a DC voltage of 100 voltage is applied to a series RL circuit with R equal to 25 ohm. What will be the current in the circuit at twice the time constant? So this is the RL series circuit. R value is given 25 ohm, applied voltage is 100. We need to find the current in the circuit. One more data available is twice the time constant. The time is t equal to twice the time constant, right? So based on that, we'll go to the solution. As the voltage source in the circuit, the expression for rise in current is given by, for this series RL circuit, the current I equal to I into 1 minus e power t divided by tau. So the t is the time, tau is the time constant for the RL circuit, time constant of RL circuit. So this is the equation for current for this given RL series circuit, right? In this we need to find the I value and this tau, what is the time constant. The time constant already given as twice the time constant. So I equal to E divided by R. These two data are available. E is the 100, R is 25, so 4 amperes. So steady current, steady state current I equal to 4 amperes. And given that T equal to 2 times of time constant, 2 tau. One more data what we have, the current in the circuit at twice the time constant, 2 times of time constant. This is tau. So T equal to 2 tau. So the given expression is I equal to I of 1 minus e power minus t by tau. Now the t value is available. T is given as 2 tau. So replace this t by 2 tau. Already one tau is there, so got cancelled. So e power minus 2. Right, the I value is 4. So I equal to 4 of 1 minus e power minus 2. By simplifying the expression, we got I equal to 3.46 amperes, right? So it's a very simple problem. We are directly using this formula. In this formula, I value is calculated as E by R. These two data are available. The time constant T, the time T and time constant T, the relation is given. T equal to 2 times of tau. Based on that, this time constant got cancelled. We got e power minus 2, so that we can easily solve the problem. The final answer is 3.46 amperes. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.